Hello, today I'm going to walk you through the problem of adding two numbers that are stored as linked lists in reverse order. So I have two numbers, 342 is my top number and 465 is my bottom number. These are stored in linked lists in reverse order, so the least significant digit is my head of my linked list, and I just go forward pointing to, increasingly significant digits as I go along through the linked list nodes. And the problem we have is we want to add these together and return a linked list that is also in reverse order. The reverse order might throw some people for a loop, but it actually makes this problem a lot easier, right? Because if these didn't have the same number of digits and they were stored properly, you might have a case where I have an extra digit, but those two digits needed to get added together. I don't know if I'm explaining that very well, but it is easier that they're reversed, and I'll show you how it works. So the first thing we want to do is we want to make sure that we have some kind of way to iterate through these linked lists. So I have this pointer P1 that is going to point to this node. I also have a pointer P2 that I'm going to point to this node on my second linked list. If either of these were null, we could just return the other one, right? Like if P2 was null, if we didn't actually have a second number, we can trivially just return the first linked list as our solution. I'm also going to have a result pointer that is going to point to the resulting linked list, and we'll set it to null initially. So just right there on the board. We're also going to keep track of our carry bits. So I'll have a carry variable, and we set that to 0 initially. So our loop is going to loop through the nodes in both linked lists. So I'm going to say, while P1 and P2 or P1 or P2 are not null, I'm going to look at the numbers at those nodes. I'll add them together. In this case, it'll be 7. I will add my carry bit, or my carry digit rather, to that, which still results in 7. I will make a new node with the value 7, and I will point my result pointer to it. And I'll have some tracking mechanism to keep track of my current node in this result, so I can keep adding to it. Next, I move my carry digit over here. It still remains 0 as we added to 7. I'll update my P2 pointer, point to this middle node, update my P1 pointer to point to this node 4. And then I'll add these together. So 4 plus 6 is 10, plus no carry, still 10. But at this point, we do have to carry. We have to account for that on our next add. So we'll make sure that we update our carry digit. And then this is going to end up being 0 because we had 10. So taking into account the carry, we're left with 0. Make that node. Point that to null, and then we update our nodes up here. So move pointer 2 to our last node, pointer 1 to our last node, and then we're going to add these all together. 3 plus 4 plus our carry digit ends up being 8. So we make our new node of 8. And I suppose I should really be explicit and say, this is actually pointing to null as well. There's no carry anymore. This gets updated to 0. And then we're going to check, what does this node point to? Well, it points to null, so we're done. This node also points to null, so we are done. And because carry is 0 and we have no more nodes to look at, we return a resulting linked list, 708, which is the number 807 in reverse order. Which makes sense because 342 plus 465 is equal to 807. All right, that concludes the algorithm. I hope you enjoyed the video, and drop a comment with any questions you might have. Thank you.